Astronomers have now learned to think in terms of globality and to consider more and more our corner of the galaxy as a set of objects continuously interacting with each other. It is no longer science fiction to claim that our solar system can be continuously crossed by celestial bodies from planetary system outside ours. And we had proof with the fascinating Cosmic Odyssey that just over 3 years ago gave us the fast transit of Oumuamua. By now, that sort of ghost ship is already near the orbit of Neptune, 4.3 billion kilometers away. And if we wanted to send it a greeting, we should raise our heads towards the large square of the constellation of Pegasus, within which lies its vanishing point. Unreachable, mysterious, or maybe not. The plan to send a probe to the trail of Oumuamua, the interstellar visitor. After all, we expected this. With the abundance of planetary systems in our galaxy, it's almost inevitable that an object escaped from one of them can pass by the Sun. And indeed, the most shared scenario in the astronomical community is that the interstellar space is crossed by objects that have been freed from the gravitational leash of their parent star and are freely wandering around waiting to find another passing star ready to pick them up. The fact is that on October 19, 2017, astronomer Robert Warwick saw for him the algorithm in charge of the analysis that in the images collected by the Pan-STARRS telescope, placed on top of the Haleakala volcano on the Hawaiian island of Maui, a point object was moving. A first cursory analysis of the orbit revealed that it had to be a comet coming from far beyond the Kuiper Belt. Then the calculations became more precise, and it came to know that the object had already passed to perihelion, the point of maximum proximity to the Sun, on September 9, 2017, at a distance of 38 million kilometers. And then on October 14th, 4 days before being discovered, it had approached the Earth up to about 24 million kilometers. The presumed comet had therefore already passed perihelion and was already rapidly receding. With the increase of observational data, it is calculated orbit became less and less approximate, and it was possible to determine that a couple of months before the object was approaching the Sun with a very high speed, 87 kilometers per second, a speed that an object belonging to the solar system could never have reached. Further calculations lead to understand that in fact the object was following a hyperbolic orbit, not closed like the elliptical orbit that comets follow, but open. A clear indication that whatever its nature was, that object had to come from outside our system and not from inside. Such a high speed also meant that the Sun's gravity could not have slowed down the object enough to keep it bound to itself, and therefore the hypothetical comet, after having circled around the Sun, was destined to exit the solar system with the same speed with which it had entered, only in a different direction. And the astronomers declared themselves so sure of this to give to the interstellar visitor a name able to underline its origin. They called it Oumuamua, which in the Hawaiian language means the first messenger from afar. From far away, yes, but from where exactly? The only sure thing was that the radiant was located in the direction of the constellation Lyra. It came from there, but it is obviously impossible to find out which was its mother star. The intense observing campaign, dictated by the need to quickly acquire any information about the visitor before its high speed pushed it too far away, soon brought to light an unexpected fact. It was not a comet. In fact, there was no way to detect a leakage of gaseous material or dust in the surroundings of the object. And at that distance from the Sun, just a few tens of million kilometers, the canopy of a cometary nucleus should have manifested itself. In terms of composition as well, observations suggested that Oumuamua looked quite similar to many asteroids found in our solar system. Dense, perhaps rocky, or even metallic, with a somewhat reddish surface due to long exposure to cosmic rays, a sign that the journey of this stellar explorer must have lasted millions and millions of years by now. So there was no doubt it had to be an asteroid and not a comet. But the surprises were destined to continue. Hang on a sec, guys, before we continue. Be sure to join the Insane Curiosity channel. Click on the bell. You will help us to make products of even higher quality. Its light curve, that is the variation of brightness over time, indicated a gap of 6 times between the maximum and minimum, and also suggested that the object must rotate on itself every 7 hours. To justify the strong variability, we could also hypothesize the presence on the surface of the asteroid of areas of different reflectivity, but almost immediately it seemed more reliable to interpret it as the direct consequence of an extremely elongated shape, with the major axis a dozen times larger than the minor one. Although it has never been able to precisely define its size, the few observations available indicated a length of about 400 meters and a width of 40 meters. Nothing like this has ever been observed. Suffice it to say that the most elongated objects found in our solar system show a length-to-width ratio never greater than 3. There was a further oddity in Oumuamua. It did not show signs of cometary activity, but nevertheless in its orbital motion was measured an additional acceleration, not due to the gravitational attraction of the Sun. The object behaved like a comet that accelerates under the thrust of gaseous jets, triggered by solar heat. But no comet had ever undergone a similar acceleration during a close passage to the Sun, and moreover, the gas emissions would have modified its rotation, which did not seem to happen. So what could Oumuamua be? A comet or an asteroid? Or what else? To know more would have been necessary to make more detections, but by the end of December 2018, the visitor had already passed the orbit of Saturn and had therefore become too faint to allow astronomers to continue observing it. Nearly 5 years after its discovery, even to this day, the appearance of Oumuamua continues to raise more questions than answers. The only thing that has become clear is that Oumuamua is not an asteroid or comet, or at least not similar to the asteroids and comets we know. And most importantly, its origin is to be found outside of our solar system. Some scientists, led by Harvard astronomer Avi Loeb, even believe that it may be an artificial object. In recent years, many teams of researchers have tried to explain, for example, the extraordinary reflectivity of the object, much higher than that of any known rock, similar, as the same Loeb came to say, to that of polished metal. What would Oumuamua be made of to reflect sunlight like that? And again, how to explain its very strange shape and the non-gravitational acceleration shown after passing perihelion. Avi Loeb embraces without any hesitation the idea that this object is a sort of highly evolved alien laser sail, and he supports in substance that it is a probe driven by the propulsive radiation of the same starlight, created by the ingenuity of an extraterrestrial civilization more advanced than ours. So it is not surprising that in the face of a mystery so dense and engaging, already shortly after the discovery of Oumuamua, someone began to consider the need to go and see. Not in person, of course, but by sending a probe. But would it really be possible to reach Oumuamua for a possible close-up study? The members of the LIRA project, funded by the Organization Initiative for Interstellar Studies, say yes, and are working on some proposals for missions with a very specific goal, namely to investigate closely the interstellar object. But how will we be able to do it given the crazy speed at which Oumuamua is traveling at this time, about 27 kilometers per second compared to the Sun, when the fastest probes ever made, Voyager 1 and 2, are traveling at about 17 kilometers per second. The idea is to chase it using the current chemical propulsion at its maximum potential, but we do not exclude nuclear propulsion and the use of laser sails, and one gravity assist with Jupiter using the so-called Oberth maneuver. The latter is done by launching a probe towards a celestial body as massive as possible, making it acquire more and more speed, until at the right time the ignition of the engines will be able to give a further boost, which will be added to the speed due to gravitational attraction. The ideal would be to use the mass of the Sun, but apparently the thing would present insurmountable difficulties because of the intense heat that the probe should bear. Researchers have proposed to use in alternative the mass of Jupiter, using previously gravitational assist with Venus and Earth. The maneuver would allow exploiting the gravitational assist of the gas giant, which would provide an escape at high speed with very little fuel. Thus, taking advantage of a 2028 launch window, the spacecraft could reach Oumuamua in 2050. Once reached the object, the spacecraft would perform a rendezvous and perform a close analysis, collecting data of immeasurable value. Obviously, we are talking about a very complex mission and a high risk of failure. And even if you could develop in time a highly efficient probe, the costs could be exorbitant. Who will finance such an operation? For now, there are no concrete plans yet, nor funding announcements from any space agency. If the project will not be followed within this year, we will probably have to give up the idea of being able to unveil the many secrets of Oumuamua, and we will have to wait patiently for another visitor. But maybe we won't have to wait long. Recently, a third possibility has suddenly materialized: the possibility of having an interstellar visitor as a permanent guest of our solar system. A study published in Monthly Notices of the Royal Astronomical Society has in fact reported the discovery of an asteroid 3 kilometers in diameter that revolves around the Sun, sharing the same orbit as Jupiter. No, it is not one of the many Trojan asteroids trapped in the Lagrangian points of Jupiter, but an object that moves on its own with the same period of the gas giant, with a great peculiarity to turn around the Sun with retrograde motion. This brings it in the unpleasant situation of having to dodge the gas giant every time it meets along its orbit. Fortunately, gravitational forces have been making sure for millions of years that the final collision never happens. In fact, the asteroid moves slightly every time it crosses the giant, alternating the gap so that it passes once inside and once outside its orbit. BZ, this is the nickname of the object used by astronomers instead of an unpronounceable Hawaiian name, is the first and only asteroid to have this peculiarity. All planets in our solar system and most other objects, except some comets, some minor satellites, and the Great Triton, travel around the Sun in the same direction, counterclockwise if observed from the North Pole of the ecliptic. If BZ was born in our system, it should have orbited in the same direction as all other planets and asteroids, the one inherited from the movement of the cloud of gas and dust from which they were formed. But so, it's not. How so? With the support of a long series of simulations, astronomers are now inclined to think that BZ has been steadily retrograde for billions of years, and that its condition should not be considered the consequence of some fortuitous billiard shot, which seems to lay heavily in favor of its interstellar origin. According to the authors, the exchange of asteroids between the Sun and other planetary systems was facilitated by the fact that 4.5 billion years ago, the Sun must have formed together with other stars, very close to each other. This allowed asteroids, comets, and perhaps larger objects such as Triton to fill interstellar space and be attracted to stars other than their own. In short, we had an interstellar visitor in the house and didn't know it. Sure, maybe not an object with the suggestive characteristics shown by Oumuamua, but still an object that came from outside, no? And at this point, the question can only be this: what are we waiting for? BZ seems in fact an asteroid quite easy to reach. Why not go and have a look?